Hello guys, welcome back to my YouTube channel. From today we are going to start a new series in which we will solve the numerical problems of Irodov. We will take one problem in one video. So let us start with first problem, that is a motorboat going downstream overcame a raft at a point A. Tau is equal to 60 minutes later. It turned back and after some time passed the raft at a distance L is equal to 6.0 kilometer from the point A. Find the flow velocity assuming the duty of engine to be constant. So let us first understand the problem. A motorboat going downstream. So we have two terms for the motion of any object in water, that is downstream and upstream. So what is the meaning of downstream motion? Downstream motion means motion of object in the direction of flow. Motion in the direction of flow. And upstream means motion in the opposite direction to the flow. Now let us first understand the motion of any object in water. For this, consider this is water flowing in this direction with the velocity Vs, which is called velocity of flow or velocity of stream. Velocity of flow. Also, we have an object flowing in water. Now, this object will have two velocities depending upon the frame of reference. Consider in first case, we are observing the object from a frame of reference which is attached to the water. Frame of reference attached to the water. Means we are standing in a boat which is also moving with the same velocity as that of water. So our frame of reference is also moving with same velocity as that of water. Now, when we are observing the object from this frame of reference, it appears to be moving with velocity v naught. This is called velocity of object in still water. In still water, or it is called velocity of object with respect to water. Now, why we are saying that this is the velocity of object in still water while water is moving? We are saying this because when we are observing from the frame of reference which is also moving with the same velocity as that of water, it seems to us that the water is at rest or water is still. That's why we are saying that this is the velocity of object in still water. In second case, we are observing the object from ground frame of reference. Means observer is on the ground. Now there may be two cases. One for the motion of object in the direction of flow, which is called downstream motion. Downstream motion. And for downstream motion, the velocity of object will be equal to V naught plus Vs, because flow will help in the motion of object. So it will increase the velocity of object. So velocity of flow will be added to the velocity of object in still water. In the second case, it is for the motion of object in the opposite direction to the flow. That is called upstream motion. And for upstream motion, the velocity of object will be equal to V naught minus Vs. Because in this case, flow will oppose the motion. So we have to subtract the velocity of flow from the velocity of object in still water. I hope you have understood all these terms, because these terms are very important to solve such kind of problems. So you should have better understanding of these terms. And the terms velocity of object in still water, velocity of object for downstream motion, velocity of object for upstream motion. Now let us draw the picture of problem. The problem is motorboat going downstream overcame a raft at a point A. We have a motorboat which is going downstream. So for downstream motion, velocity of motorboat will be equal to V naught plus Vs, where V naught is equal to velocity of motorboat in still water and Vs is the velocity of flow. Overcame a raft. We also have a raft here, and motorboat overcame a raft at a point A. Let us say it overcame raft at this point and this is point A. Tau is equal to 60 minutes later, it turned back. The motorboat moved for 60 minutes and let us say in 60 minutes it reached at point C. Now time taken by a motorboat in going from A to C is equal to tau is equal to 60 minutes. 60 minutes and in hour it is 1 hour. Now for backward motion, it turned back after moving for 60 minutes. For backward motion, the velocity of motorboat will be equal to V naught minus Vs because it is upstream motion and velocity of flow will oppose the motion of motorboat. It turned back and passed the raft again at a distance L is equal to 6.0 km from the point A. During backward motion, it passed the raft at this point. Let us say this point is B. Now raft is here. Raft at a distance L is equal to 6.0 km from the point A. Now this point at which motorboat overcame the raft during backward motion is at a distance L is equal to 6.0 km from the point A. It is at a distance 6.0 km from the point A. So the distance between AB is L is equal to 6.0 km. Also this is A, this is B. So this distance which raft has moved is 6.0 km. Also raft has the velocity equal to that of water, because raft do not have engine. So water is only responsible to move raft. So raft will have the same velocity as that of water. And we have to find the flow velocity. We have to find out the flow velocity here, which is Vs. So this is the picture of problem. I hope you have understood the problem. Now to find out Vs, we have to use the fact that mm, the time taken by motorboat in going from A to C and then back from C to B is same as taken by raft in going from A to B. So sum of these two times, time taken by motorboat in going from A to C and then coming back from C to B, is equal to the time taken by raft in going from A to B. So we need to find out the time taken by raft in going from A to B and time taken by motorboat in going from A to C and then coming back from C to B. This total time we have to calculate. To calculate this, we require the distance CB. And to calculate CB, we require AC. So let us first calculate the AC. So what is AC? AC is the distance moved by motorboat with this speed in time tau. Tau is equal to 60 minutes. So AC will be equal to velocity of motorboat and time taken by motorboat in going from A to C, that is tau. We will solve it for general formula first. We will calculate general formula. So we use general terms first and then we will put the value of general terms like tau or L to calculate the result in numbers. Now we have to find out CB. So CB will be equal to AC minus AB. AC is V naught plus Vs into tau minus L. Now we have to calculate the time taken by raft in going from A to B. So this will be equal to time taken by raft in going from A to B is equal to distance AB, that is L, upon velocity of raft, that is Vs. Now time taken by motorboat. Time taken by motorboat in going from A to C. In going from A to C, this will be simply tau. And now time taken by motorboat in coming back from C to B. Time taken by motorboat in coming back from C to B. It will be equal to distance CB upon velocity of motorboat during backward motion, that will be equal to V naught minus Vs. So we will put the value of CB. CB we have calculated here. This is CB. So CB is equal to V naught plus Vs into tau minus L upon V naught minus Vs. So this is the time taken by motorboat in coming back from C to B. Now sum of these two times, this time and this time, is equal to this time taken by raft in going from A to B. So L by Vs should be equal to tau plus Cb, tau plus this, Cb is this, tau plus V naught plus Vs into tau minus L upon V naught minus Vs. So we will use the equation here. L by Vs must be equal to tau plus V naught plus Vs into tau minus L upon V naught minus Vs. Now we will solve this equation for Vs. We will take LCM in the right side. V naught minus Vs. This will be equal to tau into V naught minus Vs plus V naught plus Vs into tau minus L. And in the left side we have L into Vs. Now we will call cross multiplying L with V naught minus Vs and Vs with this term. So L into Vs minus V naught equal to tau into Vs, V naught minus Vs, V naught plus Vs, tau into Vs minus L into Vs. So this will be L into Vs minus L into V naught. This is tau Vs V naught minus tau Vs square. This is tau plus tau into Vs V naught, tau into Vs V naught plus tau into Vs square minus L into Vs. From here we can see that this is minus, this is plus, and also here this is V naught minus Vs, sorry, V naught minus Vs. So L into V naught will be of positive and L into Vs will be of negative sign. So this will cancel out. Here is, if the terms are in opposite side, they should have same sign to cancel out. So we are left with L into V naught will be equal to 2 tau Vs V naught. V naught will also cancel out from here. So Vs will be equal to L upon 2 tau. So this is the formula for Vs. This is general formula to find out the flow velocity in such kind of problems. We can use direct formula if we are given with such kind of problem to find out the flow velocity. Now let us put the value of L and tau. L is 6 kilometer and tau we will take in hours because we are taking the velocities in kilometer per hour. So tau is 1 hour. So result will be 3 kilometer per hour. This is the flow velocity of water. So this is the solution of first numerical problem of Irodov. We will take second problem in next video. Thank you.